Hello everyone and welcome back again. Today we'll start looking on having an example how to draw the activity on arrow, which is the first method to predict the total project duration. In the previous session we looked on how the activity on arrow looks like and how we draw each activity, and if we have more than two activities, how these activities are linked together. To have a quick recap, each activity in activity on arrow is represented by arrows. Like each arrow is an activity and the activity starts here, end here, the name of the activity is written at the top, the duration of the activity is written at the bottom. And if we have another activity linked with that activity, and this is how it links, what type of relationship they have, only finish to start type of relationship. If I need to use activity on arrow network diagram, activity P will start as soon as activity A is finished. So it's finished to start. And we had an example how to draw these types of conditions if P depends on A, if C depends on A and B, and etc. And we had also the dummy activity. So today we'll have the first example. In order to draw any network diagram, you need to have three information. The list of activities here, ABC, or excavating, backfill, concreting work, or whatever, but we just name it ABC to make it easy to draw the network diagram. What else do you need? You need to have the immediate predecessor of each activity. What activity must be finished in order to this activity can start? So if you can look here that we have activity C, the predecessor of C is A. It means activity A must finish in order C can start, and etc. The third thing that you need also to know in order to get the total project duration is the duration of each activity. How much time do we need to complete each activity here? Before we go with that things, we need first know how to draw the network diagram. Then we'll start applying the duration for each activity and calculate the total project duration. But for now, what you need to know how to draw the activity on arrow. So we have this first example, we have a list of activity and we have the immediate predecessor. So let's draw here. This is the same table of that one. We need just to start drawing a circle. This is the starting point. And we have activity A and activity B. I have activity B and I have activity A. What is the predecessor of A and B? It has no predecessor. Like, it doesn't depend on anything. There is no activity must be finished in order this activity can start. So these actually two activities that they have nothing that depends, or no activity should be finished in order this activity can start. So we have activity A and activity B. They can start together. They don't depend on anything else here. This is how we start. Then what else? We have activity C. It depends on what? On B. So activity C start when A is finished. When A is finished, A is start here and A is finished here. As long as A is finished, activity C can start. So we have activity C here. C depends on A. It means as soon as A is completed, C is start. A start here, A finish here. As soon as A is finished, C can start. What else? We have activity D. Activity D, it depends on A and B. It means as soon as A and B finish, D can start. If we have D depends on A and B, so B finish here, D can start. How about A? It also depends on A. Here, yes, as soon as B finish, D can start. What about activity A? I need to make sure that as soon as A finish, also D can start. This is the end of A. How to link it with D? We draw the dummy activity. This is the dummy activity. Dummy activity. So this is the one that we had discussed. We use dummy activity, which is a fake activity with zero duration. It has nothing to do, just to help us to draw the network diagram, and it shows how the activities are linked together. What else? We have activity E. Activity E, it depends on activity C. When activity C finish, E can start. So C start here, C finish here. When activity C is finished, activity E can start. What else? Activity F. Activity F depends also on C. When C is finished, F can start. So we have also F here. When C is finished, here F can start. What else? We have activity G. Activity G depends on D and E. At the end of D and the end of E, G can start. This is E and D. So at the end of D and the end of E, G can start. We just need to adjust this one, and we need to make it directly until this point. So what else? We have the last activity is H. H depends on what? On F and G. When F and G finish, activity H can start. So how to draw it? We need to draw it at the end of activity G and at the end of activity F. This is at the end of activity G and at the end of activity F, then H can start. But we need just to adjust these two lines together to show this is D. G and H would be something like this. So this is activity F, this is activity G. H depends on F and G. At the end of F and at the end of G, at the end of F and at the end of G, it's the start of activity H. This is how we draw the network diagram. This is the final network diagram, and I have drawn it here. That is more clear. It would be the same, but you need to follow the steps, how we draw it step by step. So if we look here, you can go, this is the same table. I have A and B. They don't actually depend on nothing, so they can start together. Activity C depends on the end of A. At the end of A, C can start. D depends on A and B. D depends on A. When A is finished here and B is finished, D can start. So I use the dummy activity to show that D also depends on the end of A. So this is the end of A. We just put dummy activity, fake activity that has zero duration. It's just to show this kind of relationship. When B and A finish, D can start. Activity E depends on C. So when C finish, E can start. Activity F depends also on C. Activity F depends on the end of C. When C finish, F can start. Activity G depends on D and E. Activity G depends on D and E. So when D and E finish, G can start. Activity H depends on F and G. So when F and G finish, H can start. And this is the end of the network diagram. So this is step by step. This is the final network diagram that we have completed. The first step in order to determine the total project duration is to draw the network diagram based on the list of activities and based on the predecessor. And we must also have another column showing the showing the duration of each activity, how many days we need to complete each activity. Activity A need 5 days, activity B need 3 days, etc. The following step, in the following session, we'll start using the duration of each activity in order to determine the total project duration and determine the critical path.